Hey everybody, welcome to Cloud Lunch and Learn. Thank you so much for joining us. This is the third session in our IoT series. So with that, I will hand over to Victor.
Oh, hello guys, just 1 second. So just let me just leave everything open here. And let me come back here.
Don't worry. Guys, if you've not already, please see the link I'm about to put in the chat and register to get access to Microsoft Learning materials relevant to this series.
Okay guys, let's get started. So thank you again, Lisa, for having me today. So for today's session, we'll talk about setting up the IoT Edge device. Okay. Again, a lovely Friday today. Yes, I think for the guys that are in Dublin was like amazing all the weather outside. I think it's a sunny day, at least here for me. So for those who don't know me, my name is Victor Rodriguez. I'm Azure Cloud Specialist for Application Modernization, Data Modernization, IoT at Storm Technology. If you joined in one of my sessions before, you know that my story is really recent around the IoT, and I'm currently doing some POCs that involve smart off solutions, image recognition with the NVIDIA platform, and so on. So feel free to connect with me on LinkedIn and Twitter. Just go there, hit the button, add me. I would lovely to have a kind of conversation with you guys about IoT or data platform. I'm love about this kind of subject. Don't be shy. So for today's session, we're going to set up an IoT Edge device. So let's imagine for a second that we talk about a company called Contoso. So Contoso has product factories worldwide. Factories are equipped with production lines that have multiple machines to create their products. At the moment, they have an IoT devices connected to each machine that streams sensor data to Azure and process all data in the cloud. Due to a large amount of data being collected and urgent time response needed on some of the machines, Contoso wants to add a gateway device to bring the intelligence to the edge for processed data to not only send important data to the cloud, plus be able to process data and react quickly even if the local network is poor. We'll be setting up a new IoT Edge device that can monitor temperature of one of the machines and deploy Stream Analytics model to calculate the average temperature and send an alert to the device to act quickly. Okay, for today, we will do an introduction to Azure IoT Edge. We're going to deploy an Azure IoT Edge, create the IoT Edge Device Identity in the IoT Hub, connect this IoT Edge device to the IoT Hub, add the Edge model to the Edge device, and deploy the Azure Stream Analytics as IoT Edge model. And by the end, a quick quiz. So let's get started. But first, what is Azure IoT Edge? So Azure IoT Edge moves cloud analytics and custom business logic to device so that your organization can focus on business insights instead of data management. We can scale out our IoT solution by packaging the business logic into standard containers. Then we can deploy those containers to any of our devices and monitor it all from the cloud. So analytics drive business value in IoT solution, but not all analytics needs to be in the cloud. If you want, let's say, to respond to emergencies as quickly as possible, we can run anomaly detection workloads at the edge, for example. And if you want to reduce, let's say, the bandwidth cost and avoid transfer terabytes of raw data, we can clean and aggregate the data locally, then only send insights to the cloud for analysis. So the Azure IoT Edge is made up for three components. The first, the IoT Edge models, are containers that run Azure service, third-party service, or your own code. Models are deployed to IoT Edge device and executed locally on those devices. Just to give more details around the models, IoT Edge models are units of execution implemented as Docker-compatible containers. that run your business logic at the edge. Multiple models can configure to communicate with each other, create a pipeline of data processing. We can develop custom models or package certain Azure services into models that provide insights offline and at the edge. Azure IoT Edge allows us to deploy complex event processing, machine learning, image recognition, and other high-value AI. Azure services like Azure Functions, Azure Stream Analytics, and Azure Machine Learning can all be run on-premise via Azure IoT Edge. We are not limited just to Azure services. Anyone is able to create AI models and make it then available to the community for use through the Azure Marketplace. And when we want to deploy, let's say, our own code to our device, Azure IoT Edge supports that too. So Azure IoT Edge holds the same program model as the other Azure IoT service. Let's say you can run the same code on the device or in the cloud. So Azure IoT Edge supports both Linux and Windows, so we can code to the platform of our choice. It also supports Java, .NET Core, Node.js, C, and Python. So let's say us as developers can code in any language that we already know and use the existing business logic. And we have the Edge runtime that runs on each IoT Edge device and manage the models deployed to each device. The Azure IoT Edge runtime enables custom and cloud logic on the IoT device. The runtime sits on the edge device and performs the management and communication operations. The runtime supports several functions like install and update workloads on the device, maintains the Azure IoT Edge security standards on the device, ensure the IoT Edge models are always running, reports model health to the cloud for remote monitoring, and manage communication between downstream leaf device and the IoT Edge device, between models on the IoT Edge device, and between an IoT device and the cloud. And to finish, a cloud-based interface that enables us to remotely monitor and manage the IoT device. Azure IoT Edge integrates seamless with Azure IoT Solutions Accelerator to provide one control plane for your solution needs. Cloud Service allows you, let's say, to create and configure a workload. This is available in the cloud-based interface. So you can send a workload to a set of devices. Let's say you want to deploy a specific workload to a set of devices, and you can also monitor workloads run on the device in the field. Okay, let's start with the demo. So let's see this in action. Now we can start to configure the Azure IoT Edge. To do this, you will require two components. First, an Azure IoT Hub that you are already familiar, and Azure Virtual Machine with Linux that you act as our simulated device. So how we can create the VM? So let's say for today's session, I'm going to use an Ubuntu server VM with Azure IoT Edge runtime support from the Azure Marketplace. Let me show you now where you can find this VM because I will provision mine. Let me put here my Azure portal. Okay, let's open first my resource group that we call for this series CLI IoT 2020-08. So we can just click here in Add. And on the search, let's search for, let's say, Azure IoT Edge on Ubuntu. So let's click Create and fill out all the information required. So I'm not going to create this because I already have this machine, but there's an important piece of information that you need to be aware. When you create this simulated device, you need to pick the proper image, and the image is the Ubuntu server 16.04 plus Azure IoT Edge Runtime Gen 1, this one that contains the proper image for the IoT Edge. After you fill out the information, you can just click Review plus Create and create the machine. Okay, so we are almost ready. Now let's create the IoT Edge Device Identity in the IoT Hub, but this time, instead of using the Azure interface, we're going to use the Azure CLI. Let me just drag and drop here my terminal. Okay, if you guys cannot see, if it's too small, just let me know. Okay, let's run the Azure CLI command to create the IoT device identity. In Azure IoT Hub, with the we're gonna create this this device ID with, let's say, we're gonna call this CLL IoT Edge Device 001. So the command will be this one. I will paste here. So you'll be the AZ IoT Hub device identity create. Hub name is name of our IoT Hub. Device ID, the name that we are setting for this device ID, and with the parameter Edge enable. It's important to note the IoT device identity can, of course, also be created inside of the Azure portal. It's quick and easy, and I can show you later. Okay, we can see that the command contains information about it. Let's just enter here. Okay, let me just expand this. Okay, so we can see the command contains information about the device identity that was created to the added device. For example, we can see the default symmetric key that is here. We can see, again, that is auto-generated, and the capability of the edge is set to true, that we set inside of the parameter. So once the IoT Edge device identity has been created, you can access the connection string the device by running the Azure CLI command. Let me show you what is this command look like. So, second, let me copy and paste the command. Okay, the command will be AZ IoT Hub device identity. I will pass the parameter show connection string, the device ID, in this case CLL IoT device 001, and the hub name, the name of my IoT Hub. Okay, let's copy this value of the connection string from this JSON output and save like for reference, because we are going to use this to configure the IoT device to connect to the IoT Hub. Let me just copy here this first. And let me just paste here on a notepad. Okay, now we already have everything that we need, the VM and the device identity. First, let's connect to the VM. Here I have let me just open this new tab here. And here I have in the terminal, what I need to do to connect it to my Linux VM is pass the parameter, the command SSH, my username, and the IP address of my VM. Okay, let me type yes, my password, and we are connected. So we are connected. Let's check now the IoT Edge runtime version, just to double check if everything is in place for this. So what we need to do is first is IoT Edge version. Okay, we have the version of the IoT Edge. So everything so far looks fine. Now we need to run a command to configure the Edge device to connect to IoT Hub. But first I need to elevate the privileges of this session. So I will just type here sudo su dash. Okay, so I will elevate the privilege of my session. So, okay, now on the config edge sh script is used to configure the Edge device with the connection string necessary to connect to the Azure IoT Hub. This script config edge sh is installed as part of the Azure IoT Edge runtime. So to configure the Edge device with the device connection string for the Azure IoT Hub that we just copied like moments, when the IoT device ID was created, let's run the following command. First, I need to pass the path of my config edge sh, and I will grab my connection string that is here. And enter. So once this command is complete, the IoT device will be configured to connect to IoT Hub using this connection string that we just entered. You can see the output of the connection string configured. So we can double check here and everything looks fine. Okay, now we are going to use going to add the Edge model to the Edge device. I will add a simulate temperature sensor as custom IoT Edge model and deploy it to run in the IoT device. So let's come back to the Azure portal. We are going to open my resource group that's already here, and let's open my IoT Hub. Okay, so under the automatic device management, let's open the IoT Edge. Okay, it's open. Let's click on the IoT Edge device that we just created. Okay, we are now on the device summary pane of the IoT Edge device. You can notice the models tab here display a list of models currently configured to the device. Currently, the IoT device is configured to only run the Edge agent and the Edge Hub models that are part of the IoT Edge runtime. So on the IoT Edge blade, let's click here and set models. Okay, so on the set models blade, let's locate the IoT Edge models that is here. We can click Add button here and select IoT Edge model. So on the IoT Edge custom models pane, we can enter the values to add a custom model, let's say temp sensor. A temp sensor, okay, and use the image URI for a simulate temperature sensor. For this case, I use this default here for this lab. All the resources related to this, I'll put like by the end of the presentation, so you can come back and do it by yourself. So all the information will be there. And the model twin settings, I will set the following settings. These will be the desired properties when my device it's configured. So I just click in Add, and now Review plus Create. And in here, you can visualize the manifest with all the configurations. So you can use this manifest using the ARM templates, for example, to deploy this kind of IoT Edge device. I will just click now Create. You can notice now on the IoT Edge device blade, it's here. The list of models now include a newly added temp sensor model. The temp sensor is here. So let's hit the refresh button and check if the status is updated. No, it's not updated yet, no problem. So let me hit refresh again. Okay, so what we need to check if this specific model now is deployed inside of our simulated device. To do this is really simple. Coming back to the Windows terminal here, I'm connected to the simulated device inside of the terminal. What I need to do is get the list of the IoT Edge models. So by typing IoT Edge list. Okay, so you can see now I have the Edge agent here, Edge Hub, and my temp sensor that we just deployed. Okay, let's check if this temp sensor it's already sending information. So what we need to do is IoT Edge logs temp sensor. Okay, look like everything is fine, and send the telemetry to the cloud. You can see here the machine, the temperature, the ambient, and so on. So now that temp sensor model is deployed and running inside of the IoT Edge device, we can add the Stream Analytics model that can process the message on the IoT Edge device before sending to the IoT Hub. I already prepared 2 additional resources for this demo. First, an Azure storage account and an Azure Stream Analytics job. So let's configure the Azure Stream Analytics job. Let's come back to my resource group. I will open the Stream Analytics job called CLI IoT ASA 2020-08. And in the left navigation, let's click on the inputs here. Okay, we have the inputs here. On the input pane, let's say the Azure Stream Edge Hub. Okay, so here in the input pane, let's to create a new input, let's enter here for the input alias temperature. And then here in the event serialization format, I'll just pick JSON. And then code I'll just leave by UTF-8. And event compression, I'll just leave by none. Compression should not be used right now, but for sure, you can use a gzip or deflate formats. Is also supported by the service. I'll just click save. Just take a little some moments to open to refresh. Okay, it's fine, it's quick. So in the left side navigation now, let's select the outputs. And again, I'll click add and Edge Hub. On the new output pane, I will enter alert as my output alias. And the event serialization will be the JSON again. But for sure, you can select here another option, for example, the CSV file, if it's your output. And the format drop-down, I will keep a line separated, because the way that I'm working this. And I will keep the encoding as UTF-8. And I need to just click save here. Okay, now we just need to configure the query. I will just click it here in query. In the query pane, let's replace this default query with the following query. I will explain you why. Okay, let me just yeah. Okay. What this query is doing is looking for the events coming into the temperature inputs, that is here, the temperature input, and group it by a tumbling window of 15 seconds. So what I'm doing is looking for the past 15 seconds, grouping this information there, and then check the average temperature value within that group is greater than 25. If the average is greater than 25, that will send an event with the command property that set the value reset as the output. So what basically I'm doing is I'm processing all these messages that's happening inside of my device, looking for the past 15 seconds, looking for the average. If the average, is greater than 15 seconds, what I'm going to do is reset. That's it. Let's save the query. Okay, now to prepare the Stream Analytics job to be deployed on an IoT Edge device, it needs to be associated with an Azure Blob storage container. When the job is deployed, the job definition is exported to the storage container. So on the Stream Analytics job, below the configure, let's select here storage account settings. I'll click add storage account. Here I have my subscription, my storage account. I'll select the one that I create for this demo. That in this case is CLI IoT Store. I'll create a new container and I can call this container job definition. And we can just click save. Yes. Okay, now we need to deploy our Stream Analytics job. So to do this, let's come back to the Azure IoT Hub. I will open mine here. And under automatic device management, I will select IoT Edge. I will open my device. And I will click again in set models. On the add model step, I will add a new step here and select Azure Stream Analytics model. And here I will select the one that I create for this demo. And I can just click save. The deployment will take a few moments, but let's just wait a little bit. This process of create models can fully automate by ARM templates, so you don't need to worry. This step is just for the sake of this demo and for sake for a developer environment, and for sure you can automate this whole process using ARM templates. Okay, look like everything's fine. We can click now in the Stream Analytics job. So we can notice on this page that the image URI points to a standard Azure Stream Analytics image. This is the same image used for every job that get deployed in the IoT Edge device. So this will be the image that will be containerized and put inside of the IoT device, taking consideration the configurations that we just set in the previous step. So we leave everything here by default. I will just cancel here, and we're gonna jump to roles. we are going to replace the default routes defined with the following 3 routes. So the first one will be the telemetry to cloud. I will explain in a moment what is each one. Let me put here the parameters. So the value will be this one. And a second route will be added called alerts to reset. Let me just copy and paste here. And telemetry to Azure Stream Analytics, ASA. I go copy here and paste here. Okay, you can notice that the Stream Analytics job model is set on the value. So here you can see that the model that we just created is here and here as well. So the routes that are being defined are the first one, the telemetry to cloud. This route sends all the messages from the temp sensor model output to Azure IoT Hub. And we have here alerts to reset. This route sends all alert messages from the Stream Analytics model output to the input of the temp sensor model. And we have the last one, the telemetry to Azure Stream Analytics. That route sends all messages from the temp sensor model output to the Stream Analytics model input. We can just click now, review, create. Again, the JSON file with all the manifest, all the configurations that we just set for this case. For example, here, the image, and you can notice all the configuration that we just did here related to the desired properties and so on. So we can now just click create. And okay, yeah, it's fine. So now we need to visualize this data. So how we can do this? Let's come back to our terminal. We need to know if this model is already deployed to the device. This can take like a couple seconds. Let's check if it's already there. To check the list of models, we just need to type. Let me clear this. Okay, so we need to type IoT Edge and list. It's not deployed already, so let's take this maybe take a minute or two. Let's wait a few seconds. Let me check here on the page if everything's fine, no errors at all. Okay, come back to the terminal. Okay, yeah, so now we have our model here. Let me just clear again and list up Azure IoT. So you can see here that the model that you just created, it's deployed inside of the device. Okay, we can now run the IoT log again, IoT Edge log command again to watch the telemetry being sent by the temp sensor model. So let's do this again. So IoT Edge logs the temp sensor. Okay, everything's fine. Just waiting. Let's keep executing this command until something happens. Let's see. Let's wait until this happens. Remember that now we have a temp sensor model that's sending telemetry to the IoT Hub, and now we just implement an Azure Stream Analytics job that will monitor this temp sensor and looking for the average on the last 5 seconds greater than 25. A little bit to check if the job is running. I hope this demo works, so fingers crossed. Yeah, so we received the first message here. Let me just refresh again. Yeah, so something happened. What we can notice is that the reset command is sent by the Stream Analytics job when the machine temperature is never above than 25. This action is configured in the Azure Stream Analytics job query. So you can see here when the Stream Analytics job check if the message from the last 15 seconds in average was greater than 25, the Stream Analytics job that's run inside of the device just aggregate this information and say reset the command, reset the device, or reset the model that is running. That's what exactly that happened here. So let's check if it is happening again. So let's run again and happen again. So you can see that every time the average hit above the 25, it's resetting the model. Okay. Okay, so in today's session, we saw how simple it is to deploy the Edge model on the IoT device and leverage, let's say, all the power of the solution like the Stream Analytics. So this concludes the session for today. I will jump now to the quiz, and after that, then I can address any questions that you may have. Okay, guys? So jumping back to the presentation. So as if you participated on the previous conversation, I make always 2 questions around the current session. So feel free to take your guess and send your answer through the chat. I'll be really happy with that. So the first question is, Java is a supported language to develop IoT Edge models. Don't be shy. Hit your button here, send yes or no. Don't be afraid. This is a kind of question that you'll reach you out when you try to do the exam for the IoT developer. So feel free. Okay. A couple yes. Yeah, that's very good. Yes, exactly. The answer is yes. IoT Edge also supports .NET Core, Node.js, C, and Python. So you are really ready. Whatever the language that you like, you can go for the IoT Edge and start to develop it. So the answer is yes for this case. Second question. IoT Edge runtime is responsible for ensure the IoT Edge models are always running or run units of execution implemented as Docker-compatible containers that run your business logic at the edge. So for this, to simplify this, is the first one is A or B. Okay, some guess here. So the answer is ensure that IoT Edge models are always running. So the component that run units of execution implement as Docker compatible container is the IoT model component. Okay, so now I can address any question that you may have.
Awesome. Thanks, Victor.
Thank you.
Does anyone have any questions?
Feel free to mute yourself or send it through the chat. I'll be really trying to answer any questions you may have, guys. Any kind of device, let me just, yeah. So which device support the IoT Edge device? So I don't have a list, a specific device that supports, Raspberry Pi supports, yes. Raspberry, you can run the Edge runtime, but yeah, you can run the Raspberry Pi with the Edge runtime. You can use the Ubuntu Linux machine or Windows machine, but if I remember, I did a demo last week and I run the Edge runtime on the Raspberry Pi. Can I show your device setup at your desktop if it's possible? Let me try here. So I have a couple of devices. I have a Raspberry Pi 4, as far as I remember. It's this one. It's really simple. This one's just running a couple of tests, Visual Studio Code and things like that. And I have here as well, but this is inside of the case. But basically, this is an NVIDIA Jetson Nano with a cam that you can see in here. These are the connections that I have here. If you want to know more about this, I put inside of the resources the session that we just did for the Cloud Launcher Learn that we work with this device, the Jetson Nano, to be able to run some AI models, machine learning, and so on. So it's a really nice model. It's sad because inside of the case, and the case is already like, yeah, but let me, I think I have the box here so you can see this better. So yeah, that's basically the Jetson on device kit. So if you guys, this one's really amazing. Try this one. Yeah, basically this is my desktop today. There's a couple other ones that I want to buy, but I need to look for budget first. For Edge device, to be honest, today I'm using a lot of C. but it's my preference because I'm more familiar with C. But to be honest, I think the one that's a good fit is Python, because Python, like you can translate between Python with a lot of things. So if you're familiar developing IoT Edge with Python, you can go for a model that is already have, let's say, some data. For example, you want to do some data cleaning at the edge, you want to do some data aggregation at the edge, and Python is really handy because the amount of libraries that's available. So I think Python is a really strong candidate for this. Any more questions, guys? I think that's it. Lisa?
No worries. Thank you so much, Victor. That was great. So we just have a few slides from our sponsors. We're really lucky to have some sponsors now at Cloud Lunch and Learn supporting the initiative. It really helps. So here we've got European Cloud Conference. They've got a Microsoft Azure Virtual Full Day Tutorial Series, and they've got a discount on. So head to the website if you want to find out more about that one. And we also have another sponsor.
Sorry. Yeah.
That's all right. Don't worry. And I think Catherine usually joins us to talk about this, but she's not here. I'm not sure if she was maybe waiting to join later. But Technology Ireland. SkillNet, Technology Ireland Software have a master's program in Internet of Things, which is super cool. Catherine did join us at the end of our last session to talk a bit more about this. So if you do want to learn more about this, then please check out that session on the YouTube channel, and also head to their website to find more. I've linked our YouTube channel in the chat, so you can go ahead and check out what Catherine had to say about the master programs in Internet of Things on our last session. And that's all for me. I can see there's more chat happening around IoT devices, which is awesome. But that is all from the Cloud Lunch and Learn team and our sponsors. Join Victor again next Friday.
Yes.
Victor, for I think it's the last session in the series.
Yeah, so for the next session, we'll be creating our first Azure IoT Central app. It's really nice because the Azure IoT Central is the accelerator from Microsoft to help you go from something that is really a proof of concept to something that's really reliable as production. So connected to be aware of what is Azure IoT Central and how we can deploy our first app there.
Awesome. Excellent. Well, thanks everyone for joining us today. Much appreciated. Please make sure that you sign up for the next session. The links are in the chat. If you need them again, just let me know. And we look forward to seeing you all next Friday.
Thank you, guys. Thank you so much for connecting today.